The James Webb Telescope has simply declared the clearest picture of Proxima B in history, uncovering shocking insights concerning this possibly livable exoplanet. Join us as we set out on a venture through space to reveal the secrets of Proxima B and find out whether it very well may be the next Earth. We should take off into the tremendous region of space, where a puzzling planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin. Proxima B, found a mere 42 light-years from us, is covered in mystery and miracles. Might it someday be another Earth with seas and life overflowing on its surface? Yet, there's more. Proxima B isn't the only one in its orbit around the red dwarf star. It has an individual companion, Proxima Centauri C. Who can say what other secrets the star system holds? Maybe there's another companion that we have yet to discover. The mystery doesn't stop there. Proxima Centauri B receives roughly the same amount of energy from its star as Earth does from the Sun. Could this actually mean that there's water on its surface, maybe even life? As we venture past our solar system, we find a totally different universe of exoplanets. Planets that circle stars other than the Sun. With 200 billion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even wander aimlessly, untethered to any star, like rebel explorers in space. Among them all, Proxima Centauri B stands out as a truly remarkable and puzzling planet, with a year that lasts only 112 Earth days and a distance from its star that is multiple times closer than Earth is to the Sun. Almost certainly, one side of the planet is constantly washed in light while the opposite side remains in endless darkness. Now we should discuss Proxima Centauri, the star that Proxima B circles. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, otherwise known as Alpha Centauri A and B together. These stars make the closest star system to our own solar system. The two stars, Rigil Kentaurus and Talon, form the binary known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak magnitude of -0.27. Proxima Centauri, otherwise known as Alpha Centauri C, is a red dwarf or M star found 21 light-years from the other two stars, multiple times the distance between Earth and the Sun. It is indeed the closest star to us. Proxima Centauri means the nearest star of Centaurus in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn Aitken, Proxima Centauri remains invisible to the naked eye due to its apparent size of 11.13, which is far beyond the maximum human limit of 6.5. However, don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most effective regarding energy production. They may not produce a great deal of energy, but the internal convection process at their center keeps them shining for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. Yet the habitability of a red dwarf star like Proxima Centauri is still being debated. For one thing, it's a flare star, which means it has frequent and erratic fluctuations. As a low-mass star, the habitable zone would be closer to it than that of the Sun, projected to be somewhere between 0.23 and 54 cents. But it's not as habitable as it seems. Proxima B probably won't have a stable atmosphere, which is essential for maintaining conditions suitable for liquid water on its surface. Without it, living organisms would be vulnerable to perilous space weather, making life nearly impossible. So while Proxima B might seem Earth-like on the surface, it's far from being able to support life. Many remain skeptical, as various factors render it uninhabitable. The quest to uncover the truth about Proxima B continues, and some still hold hope. One instrument that has caught the attention of cosmologists is the James Webb Telescope. After various delays, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. As with everything in science, things are never fully as clear as they seem. A multitude of changes were required to ensure that the James Webb Telescope produced accurate images. As Abby Curve, a hypothetical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can take photographs of this light on the surface of the planet and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is multiple times denser than that of Earth's, leading to extreme heat that would make it impossible for life to exist. The quest to unravel the mysteries of Proxima B isn't without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers are hard-pressed to figure out how to study planets like Proxima B. The risks are great, but the rewards are even greater. The opportunity for a brief look into the unknown to uncover the secrets of a distant planet that holds the promise of life is one that a serious researcher will take. Going to Proxima B, supposing speculatively that the exoplanet is hospitable, might we even go there? It's the closest exoplanet to us, which makes it so exciting because it's almost like looking into our cosmic backyard. What's even more interesting is that it's roughly the same size as Earth. Moreover, its location in the habitable zone means it might actually have conditions for life as we know it. Proxima B's proximity also makes it a viable target for our quest for life beyond Earth. With it being just around the corner, well, somewhat, it's a great candidate for interstellar missions. Imagine the chance of exploring this Earth-like exoplanet. However, we can't yet go there. It's definitely on the radar for future missions as technology makes it more accessible. It's one of the most exciting prospects in the field of space exploration. However, it is no easy feat to get there. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Nevertheless, a plan has been proposed: solar sails. These ultra-thin sails could be used to accelerate a spacecraft to the Alpha Centauri system and Proxima along with it. This technology utilizes solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. With anticipated speeds of 10% to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration. It has given us a newly found sense of hope that we are not alone in the universe. The James Webb Telescope is a wonder of modern technology that has the ability to take us all the way back to the very beginning of the universe, 13.7 billion years ago. This is the carefully guarded secret. The farther away an object is, the longer it takes for light to travel from it to us. This means that the James Webb Telescope can actually see objects in the universe that are farther away than any other telescope before. In addition, it has the ability to observe these objects in longer wavelengths of infrared light, which means we can see many more distant stars with greater clarity than ever before. And guess what's even cooler? This incredible technology has the ability to shed light on the possibility of life on other planets like Proxima B. However, as with anything so remarkable, there are some limitations. For instance, the presence of an atmosphere doesn't necessarily ensure the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is unsuitable for life. And get this, the James Webb Telescope has the capacity to detect such illumination if it reaches a brightness of only 5% of the planet's dayside. Now, 5% may not seem like much. However, when you're dealing with a star that is multiple times dimmer than our own sun, it's actually a significant amount. If Proxima B has an intelligent civilization illuminating its surface, they may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants, while others resemble our own Earth. One type of exoplanet that has caught the attention of space experts is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed super-Jupiters, dwarfing even the largest planet in our solar system. However, that's not all. There are also hot Jupiters, which are gas giants that orbit incredibly close to their host star. They exist in a scorching world with temperatures that could melt metal. Imagine being able to observe such a planet up close, with its raging storms and oppressive heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres difficult to study from afar. And we must not overlook the terrestrial exoplanets, which resemble our own planet Earth. These planets come in various sizes, ranging from smaller than our world to double its size. There are even super-Earths, which have masses greater than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with a rocky mass of 7 Earth masses. Despite being close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b isn't alone. It has a companion, Proxima Centauri c, which is significantly further away from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more intriguing about Proxima c is that it appears to be an extremely bright world, potentially due to the presence of a ring system. There are more discoveries to be made in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary companion. If confirmed, this planet will be known as Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a world where the night sky is filled with stars, as well as countless other planets, each with its unique composition and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made all the time, it's an exciting time to be an astronomer. While we don't yet have an exact count of exoplanets, we do know they exist in abundance throughout the universe. However, exoplanets are not easily recognizable, and it requires advanced technology and powerful telescopes to identify them. These planets are often obscured by the glare of their host stars, making them challenging to study. But with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star not to be obscured by its glare, and sufficiently young to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, yet they provide a fascinating glimpse into the characteristics and composition of these distant worlds. Exoplanets are typically discovered through the effects they have on their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope utilized the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided significant data about exoplanets, including their size, distance, and temperature. Here are a few fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces. Exoplanets, like the planets in our solar system, can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, yet there are countless other exoplanets waiting to be discovered. NASA's James Webb Telescope is unlocking the mysteries of the universe one discovery at a time. This remarkable telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made history with a groundbreaking discovery that will change our understanding of the universe forever. But that's not all. The James Webb Space Telescope has been busy capturing amazing images and gathering data about the universe. The dazzling photographs of stars, galaxies, and dust clouds swirling and colliding with one another are truly mesmerizing, and the discoveries keep coming. A global team of space scientists utilized the telescope to compile a detailed inventory of the deepest, coldest ice ever noted in a molecular cloud. They identified frozen forms of various molecules, including carbon disulfide, ammonia, and methane, as well as some relatively simple organic molecules like methanol and straightforward ice like water. This extensive inventory provides invaluable information about the formation of future planets and stars.